What happened to little Timmy? Oh, the storm ate his brains. I think you're confusing that with zombies, sir. Anyway, we got a couple giveaways here before we. Yeah, I said that already, right? Yeah. I could tell my DEF CON story about the Switch being thrown to the audience again as a giveaway thing, but I'll save you. Woo! I've heard that 5 times, jackass. Hey, internet, catch. Sorry, I'm taunting the online viewers. I'm about to get a lot of hate mail. Like, you dick. All right, so the first 2 T-shirts are from Ghetto Geeks, and they've been kind enough to give us some T-shirts to give away. Please visit them. And you're all leaning back like you're entitled to get these T-shirts. But what I want to know is who in the room's taking the time to provide feedback on feedback.shmoocon. All right. Sweet. Technicolor even. Could someone colorize this? We can call Ted Turner. All right. It's 7:02. It's time for the keynote. So in years past, we've gone and we've invited keynotes and important people in the community to come talk. I'm not saying you guys aren't important.
Not this year.
But this year was a little different. It was, when we were looking at the talks that had come in, we saw the talk that Marsh and Steve had submitted about their work in discovering the TLS authentication gap and how they interacted with the community, and a bunch of really interesting details about how this whole thing went down. We thought, that would actually be fantastically interesting to everybody. As a plenary group, let's get everybody together, let's have them tell this story. And it didn't seem fair to give them 20 minutes to do it, so we said, hey, do you want a keynote on Friday? And they, I think, shook a little bit, but they seem to be okay with it, so I don't think they're too nervous, which is good. But I was actually on a podcast, I forget which one, Securabit. I was on like 3 podcasts last week, which was 3 more than ever before. And we were on the Securabit podcast and I actually got a little bit of a taste of what this was about. And it's a fantastically interesting story, what they went through, not just from a technology perspective, but the whole process and what you guys actually had to deal with, but from the people that liked what you were doing and didn't like and whatever. So hopefully it's a little bit of a shaman storytelling, get a marshmallow out, hold it up over your flashlight or something, and make yourself a s'more while these guys tell you a story about TLS. So welcome to ShmooCon, guys.
Thank you.
Thank you, Bruce. Okay, well, so we're going to move on here. If I can get this PowerPoint to work right. Sorry, I'm new at this. So I thought I'd start out just for a second here. By the way, I'm Steve Dispenza, and this is Marsh Ray.
Hello.
And I thought I'd start for 2 seconds here and give you a little bit of context because it's not going to make as much sense without it. So Phone Factor, which is where we work, is not remotely a security research company. We're an authentication software company, and we've had some really great security researchers working for us over the years, but this isn't exactly what we do for our day job, or even really our night job. So with that little bit of background, we do have a little bit of a history on VPN software and security protocols, which Marsh will get into in a minute as to how we found this. And then above and beyond all else, we have a very special credential, which is that Marsh's parents are actually named Alice and Bob.
Thanks, Mom. Thanks, Dad.
All right, so just real quick, we are going to attempt at least not to put people to sleep with the backstory on the flaw and how to address it. We'll talk a little bit about what the world was like during the private disclosure period, and then the public, inadvertent public disclosure, and what's happened since then, and spend a little bit of time at the end talking about some of the many lessons that we've learned along the way. So with that, I will hand it to Marsh.
Okay. Thanks, Steve. It's an honor to speak before you all. Looking forward to being snowed in with you for a few days here, and looking forward to turning cannibal with you all after the food runs out. So, in short, I was at work and interested in this stuff and started digging around, and I found a bug. There were a few things that kind of led up to this discovery. One thing is we had been having a negotiation with Microsoft about securing MSRPC traffic over S-Channel, which is something that we used in our product. And S-Channel is an implementation of SSL and TLS, and we were trying to make sure that we had strong mutual authentication over that connection. A question came up in a forum that I answered it and started second-guessing my answer later on. And we just had a series of good discussions that summer about, what was required to prevent a man in the middle over a real protocol. So I was doing security code review on code for our product, which in this case was part of an Apache module. And I started debugging down into mod SSL when I came across this curious comment, this bit of code. It says, to allow authentication to complete in this auth-hook, the solution we use is to fill a buffer with the request body and then to re-inject that request body later. This is a part of code where it's handling client certificate auth. Client certificates are they're not the most common way that SSL is used for securing websites, but it's used occasionally. But normally you wouldn't want a client certificate on your home page. You would set aside a certain subdirectory and configure that subdirectory to require a client certificate auth. But the effect of that is that the web server can't actually insist on receiving a client cert from the browser until after it's seen the request, and it can look at the directory path of the request. At which point, if the client certificate is needed, it will renegotiate the SSL and TLS. How many of you have used SSL somewhat? A little bit. Okay. Of these, how many knew it could renegotiate? There we go. Yeah. I didn't really know about it either. And I came across this in the mod SSL documentation. This comment down towards the bottom, it says, in many configurations, the client sending the request body will be untrusted. So you could have a denial of service attack in this case. An untrusted client could make the web server consume large amounts of memory. So there have been many people who have been very, very close to spotting this thing over the years. It's just kind of fun to just see how close everyone had been and missed it. So this looked very suspicious, this coding construct. Not that it couldn't ever be done right, that you re-inject untrusted data into something that's authenticated. But it seemed like the type of opportunity for error where an error would result in an exploitable security vulnerability. And I started tracing down into the mod SSL and the OpenSSL code and reading the SSL TLS RFCs just to see if there was anything that enforced this continuity of identity across the renegotiation. And I couldn't find anything. The TLS RFC doesn't really talk a whole lot about renegotiation. This was something that was introduced into the SSL v3 protocol by Netscape, and they didn't really talk about it a whole lot. I mean, the word renegotiation only occurs about twice in the whole 60-some page TLS spec. And a certain form of renegotiation where the client just initiates the renegotiation only gets half a sentence, where it says that the client on its own initiative can initiate a renegotiation of the security parameters. So many long nights and weekends later, I ended up with this, which is working exploit. If you see in the interesting part is there in the middle, following the SSL stream, what the web server sees is get/evil HTML. And that is the part which is injected by the man in the middle. And if the demo gods are smiling, I'll see if we can show this.
We were told it takes about 30 seconds for these projectors to come back on, so it hasn't actually broken yet.
That's true. There's still time. There we go. Okay, so this is my own box, my own web browser. Just, pretend you're going to a secure site, and click here. We have a nice secure website with a nice pretty picture here. All right, and when I change the routing just a little bit to enable the man in the middle, and I launch the attack program. The next time I click on this link to go to the secure website, clearly you can see there's a man in the middle. So, And the worst part about this is that the client is not able to tell. You know, there's still the secure lock icon up here in the address bar.
The input looks normal to the client.
Oh. So we immediately understood the significance of this. SSL is a critical data security protocol for the whole internet. It was badly broken. I hadn't ever had the occasion to start a blog before. I decided this was a good enough reason, but I didn't want to drop a 0 day, so I typed up a summary of, a concise summary of what the flaw was, made a SHA-1 hash of it, and posted that as an initial post. Soon afterwards, John Callis told us about the Nostradamus attack and how that was kind of a dumb thing to do. But there are 3 basic attacks to this TLS. There's the case where a client certificate is required, and that can trigger renegotiation from the web server. There's a case where the web server might be configured to allow different cipher suites based on different directories. That's probably not a real common case. And then there's the case of a client-initiated renegotiation that we initially kind of discounted that, why would that ever be enabled on a web server anyway? And then there's another attack where the web browser, which is providing client certificate credentials, those credentials are able to be taken by a man in the middle and then and transported to any other web server on the internet that will accept those client credentials and be used to validate the man in the middle's evil request. So, we were wondering about what is really the scope or the impact of this? And, the client certificate, that's not used by most websites, but it is used by very important websites who have special needs for security. The Cipher Suite upgrade attack was cute, but it really amounts to reason number 1001 to disable HT access files in a shared hosting web service. And the client-initiated attack, we weren't even sure that it would work.
Back up 1 second. One of the reasons we weren't sure that it would work is we actually initially tested that against Microsoft IIS and found that, in fact, if you try to send an unsolicited client hello, it resets the TCP connection with prejudice, and that's that. So we kind of assumed that was the end of it, and nobody used it.
So, is renegotiation worth saving? If 95% of sites can live without it, why didn't everybody just patch to disable renegotiation and then everybody will be secure again? It's not like application developers even knew that it existed, in the most part anyway. But there's an interesting parallel with this thing called IP source routing, if everybody's heard of it. Presumably that was once useful to somebody for something, but as it stands now, I think network administrators, if they don't know much, they know that IP source routing is something that you should block at the firewall, and so it's in practice not usable for serious stuff. But one thing that requires renegotiation is Tor. Tor uses renegotiation in order to refresh the crypto keys because it keeps up long-running TCP connections and TLS connections and transfers large amounts of data over them.
It also tries to hide the credentials. So
yeah, it uses client certs, and renegotiating is a way to pass the client cert not in plain text, but protected from at least a passive eavesdropper. Another thing that uses TLS renegotiation is web services. Microsoft's invested a lot in this web services framework architecture, and client certificates are really the recommended best practice for providing for client authentication in this model. It's way better than putting a plain text password in a text file somewhere that the thing reads on startup. And so our entire goal at this point was really to make sure that Microsoft's business model was protected. What does it take to get some schmoo balls up here? Jeez, God. Sorry. And then, other things that that are protected with client certs are America's only strategic UFO base at Area 51, and the canisters